Hello everyone, I'm Shweta from AstronEra and welcome to our initiative Astro Stream, where we talk about astronomy with our various guests from all around the globe, and they tell us about interesting stuff in astronomy. So as we were talking with Ellen about observational astronomy, we have today Reut with us from Israel, and she is going to talk about astrobiology with us. So before we begin with our session, I'd like to tell you a little bit about AstronEra. AstronEra is the world's first astronomy dedicated e-learning platform, and on our website www.astronera.org you can find lots of e-learning courses which answer the basic questions that you must have had about astronomy in your mind, such as where do we stand in the universe or how to do astronomy without telescope. As we just celebrated our 74th Independence Day yesterday in India, we are giving out a discount of 73% on our website. So just by using the code AstroIndia 2020, you can get 73% discount on any course that you want. So without further ado, let me get Reut on the screen and we can start with our session. Hello, Reut.
Hello, Shweta. Hello, everybody. I'm very happy to be here today. Thank you for inviting me for this talk. So we are going to be together for about 5 sessions about astrobiology. I learned my astrobiology during my PhD in Australia in the University of New South Wales, doing a PhD in microbiology and immunology. And I wanted to tell you a little bit about myself. So I'm currently living in Israel. The PhD I did in Australia. Before that, I lived in Israel, but also a bit overseas. When I was in Australia, I was part of the Australian chapter of the Mars Society, and I had the chance to work and do field science together with scientists from NASA, for instance. And I really enjoyed it. I think we're living in a great age to do astrobiology and to test extreme environments. And also we have advanced a lot our technology for life detection outside of planet Earth and also in extreme environments on planet Earth. My titles at the moment, there's like 4 titles. I hope don't worry about it. So I'm the co-founder and I was the chief scientist for DMARS, which stands for Desert Mars Analog Ramon Station, which is basically an NGO that performs analog missions in Israel. So far, we had several analog missions. Some of them were educational, some of them were international presence. And we're very happy to do science here in analog missions in the Ramon crater. It's a beautiful place. It has some of the characteristics of Mars, like hyper-arid and so on and so forth. And so we're very happy that DMARS is operational, and I myself do a lot of science with it. In addition, I have co-founded together with other people the Israeli Mars Society, which connects the people, the desert, the technology, the innovation we have here in Israel with how to settle and go to Mars. I'm also a research associate at the Dead Sea and Arava Science Center, where I work on forward and backward contamination issues and research in extreme environments. And I'm a mother for a beautiful 9-year-old daughter. And that's about it, I think, for now. I'm also a visiting lecturer at the International Space University, and I'm very happy to be here today. Now, I think at the end we will have a few questions from the crowd, from the audience here, so I can answer your question. This is just an introductory conversation between us. So should I go forward and tell people about astrobiology, or do you want me to say something else first, Shweta?
Actually, we all are very excited to hear from you, and I would not want to disturb you, but I do have a few questions to ask you, and I'm sure that I would like it, and you would also enjoy it if anybody just posts their question in the comment, and we would answer it at the end of the session, right? So yeah, we would want to know what is astrobiology, and then we can move on with more questions. So go on.
Okay, thank you very much. So I'm going to try and share my screen here for a moment. So what you see here is how I think about astrobiology. It's a multidisciplinary field of science where we put in hypotheses and we try to either prove or disprove them. These are the different topics that today we do research in astrobiology. It's different aspects. So the beginning is, of course, what is the origin of life on planet Earth? How did life began here? What was the first, how did DNA came to be? What, protein is a few amino acids together. How that come to be? How these molecules, not only how they created, but also how they interacted. And then when did we see the first, let's say, microbial cell, and then, like microbial population? This whole issue of how life started on Earth and how it evolved is a fascinating topic, and it has many aspects to it, which I will talk in our next session next week. Another thing that astrobiology deals with is about, the atomic and organic elements in the universe. Life depends on the physical content in which we are created in this universe. So it's important to understand what are the physical components in our universe, what are the constants, what are the type of elements, what is common, what is not, and from there to understand how life has been created here on planet Earth and perhaps elsewhere. One of the main issues or main theories about how life started, for instance, it's talk about the primordial soup. It has been here for several decades, this scientific theory, and we have a lot of evidence to support it, and I will talk about it more in our next session. Habitability is a fascinating issue. Since technology has advanced in the last 3 decades or so, from a biological point of view, we now understand how much life is super flexible and can survive and can thrive in very, very harsh conditions. And harsh conditions are sometimes, minus 40 degrees. It's sometimes 135 Celsius degrees. It's sometimes 1100 atmospheric pressures. So sometimes it's complete vacuum. And we're talking not only just on microorganisms, which are a simple cell, but some eukaryotic organisms has been proven to shown that they can survive extreme radiation and extreme condition. So habitability is an ongoing developing area in astrobiology, and I will be talking about that in some of our next sessions. One of the things interesting people are asking me is, why are we interested in all these extreme environments and what in the microorganisms which live there, which are called extremophiles? And the reason is that when you look at our human society and our culture and our lifestyle, is that we actually are very happy, and we use a lot of microorganisms and their products and their secondary metabolites and their pigments. We're using that all the time. We ingest them in our food. We use that to make cake. We use it, to develop beer. We use it, of course, for medicine. So actually looking for extremophiles and finding new medicines, new antibiotics, new solutions to put on your skin against the sun. We can find so many solutions out there in nature. So for me, it's a non-brainer issue. And detection. How do we detect biosignatures elsewhere? So we know how to do it on planet Earth pretty well, but what have we done so far in order, to find life elsewhere? What did the mission Kepler did? What did TESS? What is the future, missions of NASA to find life elsewhere? What's going to happen with the Mars rover, right? Perseverance that has just been launched in July, and it's going to land in Jezero crater on Mars. And why is it so important that it would land on Jezero, and what kind of equipment it might have? How do we detect life? And the basic of life also is to understand how today in science, what is life? What is the definition of life in a way that I can put a scientific tool or do certain tests that can empirically and quantify that what I'm seeing is actually life? It's not an easy question, and science now has gathered several tools and several tests, and I will go through that so you can understand what it means today for the science to say, this is a life form. Okay, it may not be alive right now. It may be dormant, may be fossilized, but we know for sure that this was a life form in the past. And it might, rehibernate again. We don't know, but I will go with you through this complex issue of what is life today. And I think that sometimes astrobiologists don't talk about, but I think it should be introduced here, is the issue of time scales. How long does it take for a life form to emerge? How long? What are the conditions? And what were the conditions on planet Earth as we understand it today in the scientific community? And it's a very interesting topic. We have now an understanding about DNA evolution, about ecological niches, about mass destructions and mass extinctions. And what does that mean for life forms here on planet Earth? And as extrapolating on it, what does it mean for finding life forms elsewhere in the universe? On Mars, for instance, Mars probably in its first billion years was something quite similar to planet Earth, according to our current knowledge. It had vast oceans, it had rain, it was a bit warmer, it even had an atmosphere, which it doesn't have. It has a 6 millibar atmospheric pressure at the moment. It's almost non-existent. But the first billion years of Mars, people now think it was very much similar to Earth. So it arises the question, so how soon did life arose on planet Earth as well? So we will talk about all this and more in details, in depth in our these sessions. And I would like to personally thank Shweta for coming here to Israel and, walking the desert for me and pitching the idea and making sure that I will be here to talk with you about it. It wasn't an easy process, I can assure you. And with all the COVID-19 going on, it's not been easy at all. But, it's good to do this, and I'm very happy that you have joined us.
Yeah, absolutely. I am very sure that everyone is enjoying this session, and they are going to enjoy the sessions which are going to come ahead in this course. So our first session is going to be on 6th of September, and we are going to talk about life and evolution. Then our second session is going to be on another Sunday, which is going to be on 20th of September. And we are going to talk about, I'm confusing. So our second session is going to be about life and evolution, which is going to be on 13th of September. And then we are going to learn about extremophiles on 20th of September. Then we are going to learn about technologies for life detection on 27th of September. And then our last session with Reut is going to be on 4th of October about the future of life in the universe. So actually just yesterday, I spoke about, we have this initiative called Ask AstronEra. So everybody always asks me, what do you think? Do the aliens exist? Does the life exist anywhere other than the Earth? And it's always so much interest around, there is always so much interest around this topic, like aliens and stuff like that. So I was trying to explain to them about habitable zones and how we have found out about 4,000 more exoplanets, and how Mars had good conditions, or even now, since it's just a bit far away from the sun, it is a little bit too cold to sustain life. Of course, you can explain better about it, but knowing that there are extremophiles which exist on extreme conditions as well, I just think that the real question is, does the intelligent life exist elsewhere in the universe other than just any kind of life, right? So, I mean, of course, it was so much fun to come down to Israel last year, and coming to Mars just gave me the feel of standing on the soil of the Mars, and it was really amazing meeting you there. And finally, we are doing this session now. So, yeah, I mean, you also told us what we are all going to learn, but I want to ask you how exactly you deal as an astrobiologist in your day-to-day life. Like, what kind of stuff you have to deal with as an astrobiologist?
Hi, thank you again. What kind of stuff I have to deal as an astrobiologist? Well, basically, it's like being a biologist, a scientist. I work half-time in the academia, so I have to make sure that I get the grants. And then if I do, I work with students and I do sampling in the field. And then I come, either I do some lab processing in the field or lab processing back here. And then I have to look at the analysis of the results. I need to write some peer review papers. And I always try to maintain a healthy network of people all around the world who are interested in astrobiology. So I have really interesting conversation with astrovirologists, people who are interested in viruses who can survive extreme environments, and perhaps we can find them elsewhere. That's super interesting, I think. And I'm also in touch with people from NASA. I'm very much interested in looking into their analog mission and how they're preparing their future human crews to withstand the long journey to Mars, and perhaps even staying on the moon can take them quite some time. And what happens then with all the microorganisms? How do you go and test that environment? So I'm really looking forward for the Artemis project. I have a good friend who just came back from the International Space Station, so I'm looking forward to hear from her. So it's basically doing a lot of also public outreach. I really, really believe that because part of my funding come eventually from taxes that people are paying for, I think it's my obligation to work and talk in the public. And I recently also developed a program for high school students, which is called the Young Astronaut Academy, in which we take for about a year plus, we take a small group of high school students and we teach them, on one hand, a lot of things connecting to space. So it's space architecture and astronomy and astrophysics and astrobiology and planetary sciences. But on the other hand, we start training them as astronauts. And astronauts have a lot of team building exercises. And what we're looking for is that eventually building a group of highly, how should we say it, people who are not only very enthusiastic about space, but know that they have the capability to actually work and live in space, which is what we aim for in our newest generations. Because I believe that today we have a high school student that might be on Mars because of all the advancements that we have.
It is such, a pleasure for our generation to have these possibilities open. But, as one of the person in our chat box has also said, lots of funds and grants go to the research and looking beyond the earth while we are facing lots of problems on the earth. Like there is lots of poverty, there are malnutrition children. Then why is it important that we spend so much amount of money and time and lots of our efforts into not just astrobiology but any kind of field? And I would like to know from you why astrobiology, but otherwise I would also like to answer this question because I am also working in this field. So I also actually have made this whole course about why we should study astronomy. And I think astronomy is the science where you have to look far away in the future. Like the rule of thumb in astronomy is that you have to think long term and you have to think big. So I'll be honest, you don't get lots of result right away after you start getting into the field. You have to have lots of patience. Maybe field like astrobiology, you can do some observations and then get the result quite fast compared to the other observational things that we have to do in astronomy. But you do have to have the patience, which is going to take us long term. The GPS that you use today, the TV that you have in your home, it's all there because astronomy exists, is because we have sent some satellites in space. And of course, it's like the basic nature of a human being to understand where did we come from and to ask questions and find the answers. So the deeper that we go into the field, the more we discover about this field. And it started just 300 years ago, I would say, when we thought that the earth was at the center of the universe. And now we have such massive understanding which changes everything around us. So, of course, to research more about this and to understand more about astronomy, we do need more grants. People do need to support the researchers. It is a shame when India was sending Mars mission and the whole world was appreciating it. When I went to Israel, lots of people who met me and I said I was from India and they said, oh, the Mars orbiter mission. Do you know anybody from there? So, people were so proud of it. And the other hand, we have some astrologers, which are in Hindi we say Bhavishya Shastrajna, not Shastrajna, but who look into Bhavishya Shastra. And so they think that astrology and astronomy kind of go in hand or something like that. And there is a limit to where you have to just appreciate the advancements that we have done in this field, and on the other hand how it is also going to solve these issues of poverty and everything in very long term goals. So I think, I'm sorry Reuth, it's over to you now. I'm talking a lot about this, taking up your time of the session. So go ahead, what do you think about whatever this person is saying?
It's a good question, and even when they did the Apollo mission, it was the same question, and not a lot of people know this, but the U.S. public was very against the Apollo missions. They said, "Why are we wasting so much time and money, our money, on the Apollo mission?" And when you look decades afterwards, it was probably the biggest experiment in national space program, what happened in the US, and it's the best that we have numbers on. But basically what happened after the Apollo mission is that you had hundreds of thousands of engineers and scientists making sure that you had the proper medicine and that you had the proper technology and you had, all these advancements that went across so many fields. So looking away into space is something that brings a lot of people to be interested in science and in engineering. And eventually that pays back double or triple or even quadruple back to your own society in a very, very big way. And I'm very sorry sometimes, but I don't think there's a lot of data out there for other countries in their space program and how that's interconnected, with what people choose afterwards and how they give back to the society in so many different ways. A lot of things that are happening now, I think they're like tactical solutions, but what you find is that you find things which are dual usage. 3D printing, that NASA had a big 3D printing challenge for building something on Mars in a 3D printing. It was in 2015. It ended in 2019. And now you have a much more mature technology of building houses with 3D technique. And that allows you to use a lot less waste in your building procedures, for instance, and a lot more interesting variation and better homes for people. So, for instance, that's a dual usage. It started from something from NASA, but now it's in a different place. So people are constantly thinking about dual usage for everything they find in space. So that's a very short answer for that. And I think we have a lot of other questions. Can you choose like four questions for us?
Yeah, I think lots of people are interested into knowing your thoughts on aliens, I would say. I mean, I'm just generalizing from all the questions now because lots of people are asking.
So what is alien?
Yeah. Do you believe in aliens and stuff like that?
Okay. So I would say that I'm from an astrobiology point of view and from a microbiologist point of view, I now think that the universe is actually filled with life. Life in general. Let's not talk at the moment about intelligent life and so on and so forth. You can find a lot of microorganisms if you send the right equipment in order to check out specific things that are related to microorganism. And of course, each planet, it's like a whole world. So our way that we search for life is actually it's like it's like percentage every time from a whole planet, so it's going to take a very long time. When you look at the universe and you have 100 billion stars in our own galaxy, and let's say 80% of those stars have planets around them, and let's say maybe only one planet might have had a life-inducing conditions, and you take into the consideration that it's like light years and light years and light years away from you, and you take into consideration that we're still using chemical fuels for our rockets, which don't even get to any like 0.01% of light year speed, then what you realize is that even if there is intelligent life anywhere in our own galaxy, let alone the entire universe, we have no way of finding them or connecting with them because the universe is vast. Like one of the things I try to do, and I don't always succeed, is that I try to, people say, oh, we find this, exoplanets and it's like an Earth size and it's great. So when can we visit it? And then I translate the distance in light years to the length of my country. Okay, I have a very small country. Israel is a very small country. Really tiny country. So you're going to need, like, for the closest Alpha Centauri or the closest exoplanet, you're going to need like millions of the state of Israel, one on top of another. And then you take into consideration how long does it take you with a car to get from the bottom, from the south to the north. And then you sort of realize it's going to take you like 300,000 years in a car to get to those planets. What do you do with that information? It's why would you we don't have the right technology at the moment to jump over these amazing distances. And I'm a big fan of Star Trek, and I'm a big fan of all these things, so I'm very happy if we ever had something like a warp engine, but at the moment we don't. So we can't at the moment. And think about human species as well. Like, we have a generation life of 17 years, 70. That means that where do you go in the universe in 17 years, or maybe 200 years? It's nothing. Such a tiny portion. So it's an interesting question. I hope there are aliens out there. When you look at the statistic and you look at the sheer numbers, huge numbers of planets out there, then I'm pretty sure there is an intelligent life form somewhere. But the chances of us actually meeting or having some sort of communication with them are extremely infinitesimal, like really small, and in human life are practically non-existent almost. So it's an interesting question. Thank you.
Of course. So we are getting so many questions, but a lot of them I think you are anyway going to answer in the sessions that are upcoming. So I'd still generalize a few. Like lots of people are asking what are the similarities between Mars and Earth, and possibility of life on Mars. So if you have if you can show some light on that.
Great. Yes. Okay. That's a great question. So today Mars is nothing like planet Earth, to start with. In its first billion year, it might have been more. Today, it's completely different. Why it's completely different? It doesn't have any ocean. It doesn't have any water cycle. We don't know anything about the gas. Like on planet Earth, we had a really good, because of photosynthesis and because of the water, we have a very good idea about the geocycles, the geobiological cycles that move our planet. It's really big issues, but we have a lot of data on it. We have satellites. We know what happens with carbon dioxide, what happens with oxygen, what happens with the nitrogen, what happens with sulfur, all around the planet, and what happens with water, molecules of water, where they go, and so on and so forth. Nothing like that on planet Earth, on planet Mars, of course. It doesn't have a magnetic field. Its atmosphere is 6 millibars, which is like 1,000th of the pressure that you have here on planet Earth. It means that if you have water on the surface, they'll completely evaporate. Like you can't have liquid water today on planet Mars, and liquid water are essential for us today on planet Earth. Everything depends on liquid water. We're very, very different. It used to have, the Tharsis region is a region which has 4 volcanoes. One of them is the highest in the solar system. It's called Olympus Mons. So what we now know from a lot of observation is that there are many lava tubes, which are huge lava tubes in that, specifically also in that region. And what we're thinking now is that we know that life here on planet Earth can evolve in caves and can live very happily in caves. So one of the things we really want, especially astrobiologists in my area, we really want to send something that will look into caves and specifically into lava tubes. We know microorganism can live without oxygen very well. We know now microorganism can live well without any light. Mm-hmm. We don't need the sunlight as a source of energy. We have other sources of energy, and we need to send the proper equipment in order to go into these caves and so on and so forth. Additionally, it's very cold on Mars. So I would expect that underneath the regolith in caves, you would have a very stable atmosphere and a very stable temperature, which will induce a relatively comfortable place for life, perhaps. So that's, again, you have to go underground in order to find it. And one of the most exciting things that, I don't know if you're aware, but Antarctica has a lot of lakes underneath the surface. It's like a Swiss cheese, we call it. It has a lot of underground lakes. Very cold temperature, but we do find life forms. We find cyanobacteria, thousands of years old, which are able to survive those conditions. So I'm thinking that if we can find a place on Mars that is underground, it has liquid water, okay, because it's not exposed to the almost vacuum of the upper levels, and it has this constant temperature, that I'm thinking that we can find life forms perhaps that are alive today. Mm-hmm. I'm really looking forward to the Jezero crater's finding. I think they sent a very sophisticated equipment this time, JPL. The Perseverance has like 27 cameras, and it has a lot of things on it. So I'm looking forward. I think they might be able to find evidence for stromatolites, which is something I will talk in my next in my next session, and I'll explain in details what are stromatolites, why are they important for the beginning of life, and why are they so important if we find them on Mars. I'm not the only one thinking about stromatolite in Mars. Already in 2015, scientists from NASA have published a peer-reviewed paper saying, look, just from looking at, Gale crater, which is a very old crater that used to be a big ocean, a very shallow, big ocean on Mars. Just looking from the satellite, what we see is the morphology and the topology of the land. That's exactly how dried up deltas on planet Earth look like with stromatolites. And I'll explain that significance of that finding and the significance of finding stromatolites on planet Mars. It's people should think also about, why are we looking for life on Mars? What's the whole, and I'm going to talk a little bit about that also in my next session. What is the importance of finding life elsewhere? That's outside of planet Earth. How important or not important? It's a discussion that I do a lot with the public. I think it's a good question. We always need to question ourselves. You're a good scientist if you're constantly questioning, you're constantly skeptical, about ideas, and you don't take anything for granted. That's how I see it. It's an investigation, and you need to think and rethink and rethink until you get it right.
Yes, of course. Even I,
So
that question also caught my eye,
excellent
which asked
question. Thank you very
why
much.
we should find life even on Mars or elsewhere in solar system or outside of solar system. So you just spoke about finding some microorganisms in very cold environment, which kind of reminded me of this small research that I kind of did when I was doing an assignment in my astrobiology course, and in that I kind of wrote that the Europa, which is satellite of Jupiter, it has liquid water under its surface, right? So the surface is filled with frozen ice, and then under that, too much under that, there is liquid water. So if we consider like three main conditions that any planet or any surface of any planet or satellite would take to sustain life. First is its distance from its parent star, which gives it enough temperature to sustain life. And also keep liquid water. So considering Europa, it is getting some kind of energy from Jupiter. So what do you think about the existence of life or extremophiles on Europa?
I love Europa. I really, really love Europa. The minute that they said that they found like underwater oceans, which are probably pretty brine, by the way, very salty, I was ecstatic about that. I think the chances are really, really high to find life in Europa's oceans. The only issue is that it takes 8 years to get there.
Yeah, you were talking about the distances, and actually it's very hard to get hang of the distances, how far the planets, not just in our solar system, outside of our solar system, even to, for the sun to send its sunlight to Earth, it takes about 8 minutes, which is long time. So we are kind of looking back in the past to the sun 8 minutes ago. So the light is the fastest element that we know which travels in space, and it travels about 3 lakh kilometers per second. So yeah, that's very fast, and it covers lots of distance. To reach to the last planet in our solar system, the sunlight takes about 4 hours. So it gets,
wow.
It takes so much of time. So if you even want to reach to the last planet in our solar system, is going to take a long time, because we cannot travel with the speed of light. And to go beyond that, to find life elsewhere, we have sent Voyager missions, which we are expecting for some alien intelligent life to find out, and then figure out where we stand in the universe, and reach out to us. So yeah, I also I was just telling yesterday, but I like to tell the story a lot. People ask why aliens have not contacted us. So I would like your view on this. If we all are saying that there are aliens out there, intelligent species might be out there, why they have not reached to us if we are reaching out to them with Voyager missions and stuff like that?
Wow, that's a big question. I don't know if I can answer it very well, but let's say it this way. Our universe is about 13.6 billion years old, right? That's how we know now from astronomy. It's about 13.6.8 billion years old. Our own solar system is about 4.55 billion years old, I think. It's an interesting question. How long can does it take for a civilization to really reach really reach a level of technology that they can send something which would be more than speed of light and that would be interpreted correctly by the other side that they're sending it to? We have no data to corroborate this or even to speculate. So you will need basically a situation where you have two civilizations who are both capable of sending and receiving something which would be hopefully faster than the speed of light. So still in their lifetime, they will be able to communicate with one another. Mm-hmm. And I think that's very hard. That's probably I don't know it could be an impossible situation. So it could be that there is some sort of a civilization out there amongst all the billions and hundreds of billions of stars in our universe. Okay, so our galaxy is just 100 billions, and the entire universe, it's a lot more. But that civilization for us to actually to understand it and understand their message, it's a very complicated and heavy task, because if they would want to reach us while we're still alive and kicking on planet Earth, they would have to use a message system that is faster than the speed of light. And even though it's faster than the speed of light, it will end in a type of communication that we today would be able, with our bare hands, eyes, and technologies, understand that it's directional. So I think it's almost impossible. Mm-hmm. What people are asking for. I do think there is intelligent life probably elsewhere. Like I said, it's a really huge number of planets and stars, but I don't think we will be able to communicate them until we reach a much later stage, if we survive ourselves, of course, and how what's happening, and get to the point where we can actually activate a better than light speed technology or communication.
Yeah,
I don't know how to do that.
Yeah, exactly. I mean, the point that you mentioned, that with what means would we communicate? So from this, I remember somewhere that I read that somebody asked this particular question to Dr. Neil deGrasse Tyson, and he answered saying that they might have tried to come to us, they might have passed by the Earth, and while passing by, they must have thought that we are not intelligent enough species. So just the way you wouldn't talk to a bug in your garden thinking that it might not be able to understand you, the aliens thought that we were not worth spending their time on, which might also be possibility. We think that we are such intellectual and very progressed species, but we might not be it. These aliens might be even further, even ahead of us in technology and in everything else. Okay, so I think this conversation is never ending, and I'm sure in all of your sessions you're going to cover most of the questions that are being asked. I'm so happy to see that everybody is enjoying this session, and it's a really interesting topic. And I swear, the way Reut put everything in her words and explains everything very simply, it's really amazing. So before we go,
Thank you very much.
Before we go away, do you have anything else to share out with us?
No, I just want you all to stay healthy until our next session.
Yes, awesome. So AstronEra is bringing you these astro streams, and we are very thankful to Reuth that she decided to join us today. And it was very fun talking to you, Reuth, and we are going to end this session now. Before going back, I would like to remind you all that we are running a discount on our courses on astronera.org. So you can go up there, use the coupon code AstroIndia2020 and get 73% discount on any of the course, on whichever course that you would like to enroll in. So thank you very much for joining us, Reut, and thank you very much everybody who has joined and asked questions in the comment box. I'm sure that Reut is going to go through them. I'm going to go through these questions later, and we are surely going to cover the answers of these questions in our upcoming sessions.
Absolutely.
Yes.
Thank you very much.
Thank you very much. Bye-bye.
Bye-bye.